Show that the medians of a triangle meet at a point 2/3 of the way along each median from vertex to opposite side. It's quite a tricky one, this one. I'm going to start by drawing a diagram. And I'm going to call this vertex O, this one A, and this one B. And I'm going to define a vector A that goes along here and a vector B that goes along here. Now the median goes from the vertex to the midpoint of the side opposite. I'm going to call this point X. And we don't need to consider all three medians. If we just consider two of them and show it's true for one, well, we could have started with O at any point. So we'll have proven it. So I'm also going to take a median down here and call this point Y. And I've been labeling in blue, so I'm just going to go back and redo that. Okay, so let's consider AB to start with. AB, we'd go backwards along here and then forwards, so that would be B minus A. So AX, since we know that X is the midpoint, is a half of B minus A. Now let's call this point where these intersect, let's call that G. And so OX, so let's think about OX. I'm going to go from O to A and then from A to X. So that's going to be A plus a half B minus A. And if we expand and simplify that, that's going to give us a half A plus B. Now OG is part way along OX. We don't know how far. We're going to hope to show that it's 2/3, but we don't know that at the moment. So what I'm going to do is say OX is lambda over 2 A plus B. So lambda is the fraction of the way along. Just noticed a mistake here. That's OG that we're talking about just there. Now, we want to go to OG from O to G. We want to do OG by a different route. So what I'm going to start by is thinking about AY. So A to Y would be backwards along A and halfway from O to B. So A to G would be some fraction of the way from A to Y. So I'm going to say that fraction is mu. Like so. And then we're interested in going from O to G. So that's going to be A plus mu minus A plus a half B. Now both of these, 1 and 2, are ways of getting from O to G, and in vectors that means they must be the same. So I've got lambda over 2 A plus B has to be equal. Now if we expand this out, that's going to be A into 1 minus mu, and then we've got plus mu over 2b. Expanding this side gives us lambda over 2a plus lambda over 2b, and that's going to be equal to a 1 minus mu plus mu over 2b. So if we consider the b vector, we've got lambda over 2 equals mu over 2, and that must mean that lambda is equal to mu. If we consider the a vector, that gives us lambda over 2 equals 1 minus mu. And then the fact that we know that lambda and mu are the same gives us lambda over 2 is equal to 1 take away lambda, bring that one over, and we've got 3 lambda over 2 equals 1, giving us lambda equals 2/3, and of course mu is equal to 2/3. So that does the trick.